Hi, my name is Billy Terry and I'm the product manager for sensor sampling, and today I'm going to be showing you the operation of the LGSS sample system. That's our liquefied gas sample system. This particular one is designed for collecting samples of a high vapor pressure liquid and allowing you to transport it in a sample cylinder from the field back to the laboratory. Now in this particular case, we have our cylinder connection at the bottom and we have a flexible hose on the top. This one is actually designed to come off of a fast loop. So you'd have a process line where you could draw some sample off of, and then you'd return it back to the process, typically on the downstream side of a control valve, maybe across a pump, wherever you can get differential pressure to make sure that you get good, adequate flow through the sample system. Now, as the operator walks up, typically they're going to be bringing with them a sample cylinder from the lab. Now, this is going to come from the lab. It's going to be purged out, typically with nitrogen, and it's going to be empty. So when they bring this out, they will simply drop this down into our saddles here, which guide the quick connects together to pop into place. And then it's also secured by having that captive saddle there to make sure that that stays in place and it's properly aligned so that you don't get any leaks on those quick connects. And then they have one flexible connection for the top with a flex hose. Now, this one is a bottom mount, but typically you can also have a connection at the top and then have the flexible hose at the bottom. Either way, it's still functioning the same way. It's giving you a nice way to secure the cylinder and get it in, but then to also have a flexible connection so that you can pop it into place. Can't have two fixed connections. You'd never be able to get the cylinder into place. So once that is installed, you'll notice here that we have a set of operating instructions that the operator can follow. Everything is here visible for them to follow those instructions to get a good representative sample. So as long as those are followed, they should have no issues collecting this sample. You'll notice here we have a four-way sample valve that has two positions. It is either recirculate to process, also referred to as bypass, or sample. When it's in sample position, you actually have sample flowing through the cylinder, and when it's in recirculate to process, the cylinder is isolated and you just have the sample coming from the process line, going through this four-way valve, and then back to the process line. So once the operator has installed the cylinder, and again, they're following the instructions that are right here on the front of the sample station, they will ensure that the sample cylinder valves are open. That allows the sample to be able to circulate through there in the sample position. So essentially they will walk up, put the cylinder in, make sure the cylinder valves are open, and then they will turn that to the sample position. What that does is that now, instead of the sample coming in and going right back to the process line, now the sample comes in, goes down through this site flow indicator. So there's a little impeller in there that's going to be spinning as process is flowing through there. You can see we have our flow pattern going, showing that the sample is coming down through there. The little impeller will be spinning so they can actually have visual indication of flow. Then it comes down and goes to a T that is back onto this pressure gauge here, so they'll actually be able to see the process pressure that is flowing through this sample system. And at that point, it can either tee off and go to this venting valve, or it can come over here and flow up through this cylinder. Now this valve is closed normally, so it's going to go through and it's going to start to fill this cylinder from the bottom. Now for high vapor pressure liquids, we always want that cylinder to fill from the bottom to push out any of that nitrogen from the lab, purging it out, pushes that out, fills it up, goes out the top, then goes through this flexible hose back to the four-way valve, and then back to the process. So as long as this is in sample, it is circulating through here, making sure that they get a good, fresh sample in that cylinder, which is obviously the reason that they're wanting to use this, is to get good samples, but to also protect the operator from harmful chemicals and also ensure that there's no release of vapors or product to the atmosphere. So once they've allowed that to circulate momentarily in sample, they will rotate that valve back to recirculate to process. Now it is only coming into the valve and going back right back to the process line, and we've actually trapped this loop of sample in there. Now, at that point, what you could do is you could remove that cylinder and just take it back to the lab. However, the problem there is that cylinder is 100% liquid full. And you don't want that. You cannot have this transported with a high vapor pressure liquid with it 100% full, because what can happen is through it moving around and heating up from the sunlight, or just transporting it around and it building up additional pressure, there's nowhere for that pressure to go, so you can end up having a rupture of that cylinder, which is a really bad thing we don't want to happen. So at that point, once they're back and recirculate to process, the idea is that we're able to get we want to be able to obtain an outage in that cylinder. So the flow meter, or the flow indicator that we have here that was showing the flow going through it with our little impeller inside there, is also going to give us the ability to see the level in that cylinder. So what we would do as an operator is we'd go and start opening this vent valve. Now as we open that vent valve, we are going to begin to drop the pressure that is in that loop. As that pressure drops, that liquid that is staying in a liquid state because of the pressure is going to begin to turn to a vapor. It's going to begin to flash off, vaporize, and as it vaporizes, gravity is going to hold that liquid down, and the vapor is going to begin to migrate to the upper part of this flex hose and the top, and all the other piping that's behind here. It's going to migrate up into that area, and our liquid is going to be held down. So as we open that valve and we watch that level, as soon as we begin to see a level in that sight glass, we will shut off our vent valve, and that's going to stop it from vaporizing any further. We're going to have a nice level in that sight glass, and that is going to show us the same exact level that is in that cylinder. We have equalized it and it is level, and now we want to get that cylinder removed with that outage in it. So what we'll do at that point, follow the instructions again, we'll close our sample cylinder valves. That traps the sample in there with our outage. Now the cylinder could be removed and not have to worry about overpressuring during transport. And now before we remove it, we want to make sure that we remove all the remaining pressure and the sample that is in the quick connects. So at that point, we will open our vent valve one last time and allow our pressure gauge to go all the way down to 0. As that goes down to 0, any remaining liquid or sample that is in the quick connects and the rest of the loop will all vaporize and go out the vent line to the flare or to a safe location away from the operator. And at that point, then we will close our vent valve, and now we can safely and effectively remove the sample cylinder, disconnect the quick connects. We can take this quick connect and we can either hang it up, or we can pop it into place. We can put another cylinder in place if we want to, but ultimately the system at that point is in recirculate to process, so sample is flowing through this valve and back, but everything else has been properly vented, and now we can take this cylinder that we know has a proper outage in it. We can take this back to the lab knowing that it's not going to overpressure, that we've got a good representative sample, and the lab can take this, hook it up to their GC, and get all the results that they need to of this well-collected sample, and it'll be ready for the next time. So thank you very much for watching this video, and I hope you found it to be very informative. Thank you.